Bismillahirrahmanirrahim. Assalamualaikum to everyone. Hello, my name is Ali Zaim and I'm with my partner here, Daniel Hakim. And today we will explain to you on our project called the Autonomous Grease Trap based on the Internet of Things. Now, let us start with Daniel Hakim.
Thank you, Alif Zaim. Now we will go for the introduction. So what is a grease trap? A grease trap is a water filtering device to separate the fat, oil, and grease, also known as FOG, and also food particles from the wastewater to the tank. So what is the autonomous grease trap? So the autonomous grease trap maintenance system based on the Internet of Things is designed to solve the problem they are faced with a normal grease trap. So now let's have a look into a standard grease trap. We can see that this is a standard grease trap that is not equipped with an Internet of Things device. We can see that there are a lot of limitation and actually few features on this standard grease trap. And also in Malaysia, the municipal authorities enforce that all commercial restaurants are required to install a grease trap in the kitchen. There are also a quota rule, or also known as 25% rule, where the water level inside the grease trap shall not exceed 25% of its capacity, or if it exceeds, then the restaurant will be fined a 1,000 ringgit, approximately 250 US dollar. So now let's have a look into the manual way of cleaning a grease trap. So first, the worker will remove the lid of the grease trap and then they will begin removing the grease from the top, then go to the bottom, and lastly scrape the sides and inspect the inspector. So we can see that this problem is not only tedious, it is also unhygienic and unhealthy to the worker in a long-term condition. Not also to mention that this is highly worker intensive and thus resulting in a high cost of maintenance. So now let's have a look into the problem statement. We have three problem statements for today. So now first is the food waste. You know that food waste mostly contribute to the water pollution. And if this thing is unchanged, then it can cause major harm to the aquatic ecosystem. Then for the stinky odor, we know that most food waste consists of oil, melted fat, fat pieces, minced meat, and vegetable scrap that will produce foul smell after quite some time. These can dangerously harmful the worker when they are doing maintenance work. And lastly, the high cost. The cost needed to repair and maintain the clogged pipe due to solidification. This is very work intensive and can result in a very high cost if the problem is unsolved for a very long time.
Alright, so maybe a lot of you are wondering, how does a grease trap work? Now, I will explain to you how does it work. So as you can see in the picture, there are 5 ways, a flowchart in how a grease trap works. So firstly, when the water from the grease trap will flow into an inlet pipe. Secondly, the grease that is less dense than water will float above the water. And then thirdly, while solid food that is more dense than the water will sink to the bottom. Then the waste over will flow out through the crossover pipe into the secondary tank. And lastly, the wastewater will flow out through the outlet pipe into the sewage pipes. Alright, next. Now, for the proposed idea or for the objective of the autonomous grease trap, the objective is to design a smart maintenance system based on the Internet of Things and to do the maintenance service for the normal and standard kitchen grease trap. Alright, so now this is an example of the prototype that we have built. It contains 7 parts. The first is the lead acid battery and alkaline battery. Second, hose. Thirdly, a water tank. And then we have Arduino. And then we have an ultrasonic sensor. And then we have a turbidity sensor. And lastly, we have a centrifugal mini pump. Now let's move on to the next slide.
So let's look on how does our autonomous grease trap works. Okay, now, so for the input, we have the turbidity sensor and the ultrasonic sensor, which the function is to check the quality of the water and to check the volume of the water level. Then we also have an Arduino to process and computerize the input data according to the coding that we have done. Then for the output, we have a centrifugal pump to actuate water whenever the data is received, is controlled up when the coding uploaded. Then we also have link application as the output to show data received from the sensors. So now for the autonomous grid-set flowchart, we can see that if the turbidity is less than 50% and the water level is exceeding 70%, then the autonomous grid strap will start to work in their own ways. Then if the turbidity is more than 50% and the water level is less than 70%, then the grid strap will cease to work.
Alright, moving on. Now we will move on to the feasibility or market potential of this project. So for the market potential or feasibility of this project, we target these four primary targets, which are schools, restaurants, hotels, and property developers. So for all these four main targets, we have found that most of them they are more likely to place kitchens or maybe cafeterias. So in our opinion, this project is very suitable for these four main targets. Moving on to the next slide. So for our project, there are three impacts. The first is maintenance work. So as you can see, what is explained by Daniel Hakim earlier, as you can see, the maintenance work, the contractors who are doing the cleaning part has a big burden, and through our project, it reduces the burden of maintenance work. And for the second impact, the contractors who are cleaning these grease traps can also prevent themselves from facing any illness such as typhoid that are related to cleaning activities. And thirdly, for the environment. So for the environment, our project can restrain water pollution by minimizing any risk of failure or water discharge. So, in conclusion, our autonomous grid shop based on the Internet of Things is suitable to be implemented in any other countries as it is parallel to the fourth industrial revolution with the usage of Internet of Things that has been embedded. Alright, moving on. So these are the references that we have used to refer or have some guide. Alright, that is all from us. Thank you.